Hi, afternoon, Mr. Shan.
Hey Paz, afternoon. How you doing?
All right, so I completed quiz two today, but I had
Mm-hmm.
an issue with one of the questions because it didn't specify how much decimal places you were supposed to put it to, and I ended up
Mm-hmm.
putting it to two decimal places. When I checked
Mm-hmm.
the solution, it just put it to one, and it gave me all of it wrong.
No
But
problem. I can fix that for you. Not a problem. That's the same thing. Asia and Michael were talking about the other days. Not a problem. Easy
yeah,
fix.
all right. So what I should do? Send the code or just let it be?
Yeah, I can. Yeah, I can go in and do that one. Yeah, sure. Go
Oh,
ahead.
all right.
But I have a bone to pick with you. Or you never come here in a
What's that,
plastic.
sir?
Or you not come here in a plastic jersey.
Class? No, remember, so I was at graduation.
So was I.
So I should have been at class. I thought you said there was no class.
Did you hear what I asked a while ago? What was my question?
Sir, I asked we never come early for graduation.
Oh, I thought you said how I wasn't at class. Oh, sir, I didn't see you. I only saw you on the stage, and then by the time when I went outside, I never see you, sir.
All right, man. Never mind. You got one more graduation, you know. You got one more here. All right, congrats again. Congrats, Asia. Congrats, congrats. Proud of you guys.
Yes, sir,
Um,
thanks.
where's Mikey?
I guess he's gonna be a bit late.
What about Carlo?
Carol?
Yeah, no man.
Alisa,
Henry, Alisa.
Oh, you haven't seen her in a while, sir.
Yeah, man. So that's why I asked because I want to know if she's still a part of the program.
I have no
Haven't.
idea. I haven't seen her in some of the classes for some time now.
Yeah. All right. Give me half a second, please. Hold on.
Good evening, sir.
Them I go Sunny here.
Sir, what would know?
No, I just asked for you and pass say he guessed that you're going to be late. So them I go son you. Them I go son you. I don't know if where you are if sun shines, but them I go son you.
Well, tomorrow is a rainy day.
Oh well. Then I go sun you today, but you'll get sun. All right. I'm gonna there are how many of you now? There are only three of you. All right. I'm gonna give you another 4 minutes thereabout. See if you can sort out yourselves. Maybe get a cup of tea. And then we'll begin in another couple of minutes. All right?
Yes,
All right,
sir.
sir, no problem.
Oh,
Cool, cool.
sir, big up on
Uh-huh.
your presentation last week at graduation.
Uh, thank you, sir. I appreciate it.
Yeah,
Uh,
I was amazed that the science presenters building and pure and apply spoke
yeah.
proper standard English than
Yeah.
those of me not getting in trouble
You,
tonight.
you, you know, we went to school and did English language, you know, it's not only math alone we teach and chemistry and bio and physics.
Was it, everybody was laughing, you know. They were like, wait,
You
interesting.
serious?
Yep, it showed.
Why were they laughing though?
They were like, but those persons are from the faculty that deals with English language. So why are they sounding like that? They were speaking broken English properly.
I just wanted to present and just get off the stage. So I
I
just
see
did
it.
my stuff and just cut.
I literally saw it.
Yeah, man, I just did my stuff, my little one piece, cut. But me while at the one pass, you know, because the one pass come in at the place, you know, and the boy don't you go come heal me up, you know. But I'm going to catch him at the bachelor's graduation, man. Make him stay there, man.
Yeah, what?
I'm going to catch him at the bachelor's graduation. Hey, make sure they ain't pass.
For
Of
we're gonna
course,
do
sir,
it.
I'm gonna do this, sir.
Me,
Okay.
him,
But
Asia,
Asian
and
have a
Carol.
choice.
What are
Asian
we
have a
gonna do?
choice, you know. Asia, I forget there. Pana yai lead. By the way, where is Dowdin? A long time I see Dowdin, you know. Somebody call her for me, please.
Yeah, we're doing
A
in there.
long time I see Dowdin. All right, I'm gonna sort out my device. Give me a minute. I soon come.
Yes, sir.
Cool.
Mhm.
Sorry, guys, I got kicked out. Are you guys hearing me?
Yes, sir.
Yeah,
Come on.
sir, we're
Yeah.
hearing you.
Yeah, sorry about that here. But I had to change. I had to change devices. All right. So last class, um, we had what I would call a very interesting, a very interesting um presentation of how to calculate or least squared regression. And you guys did pretty well. I am very proud, as a matter of fact, um, on what it is that you guys did. And tonight, I would just love to be able to build on what it is that we presented last time around. I know it was last week this time, because on Thursday we had a graduation, so there was no class, right? So I really want to build on what it is that we did, build on what it is that we did, and and to see if we can take the question to a further level of discussion. One of the things that we one of the things that we didn't do, well, that I didn't do with you, is to have an interpretation of what it is, an interpretation of what it is that we would have looked at. So here's my interpretation. So based on the calculation we got the least squared regression to be negative, to be y equals 1.5183 plus x plus 0.305. So that equation is the equation of a straight line, and it will give me different relationships. It will give me different relationships of what it is that we're doing. So hear my interpretation. So remember, the whole business was when found how many hours of sunshine versus how many ice creams were sold at a shop from Monday to Friday. So that was a scenario. And then we looked at it, we were able to get our calculation. Now it is that we need to interpret what it is that we're getting from it. So Wayne hears the weather forecast, which says we expect 8 hours of sun tomorrow. So he can use the above equation, that which is the least squared regression equation, to estimate what amount of ice cream he will sell. So when he substituted 8 into the formula, the 1.5183 times 8, and added to the other stuff, he got 12.45. Can he sell 12.45 ice creams?
No, sir.
No,
No.
sir.
What is the minimum is he allowed to make? What is the minimum he's allowed to make? Tell me the minimum he's allowed to make.
Sir, 12?
What is the minimum ice cream that he's allowed to sell?
12. Well, one. Hold on now. 14. 14 ice cream in a case. So I think the minimum would be 14.
So he'll be able to sell a minimum of 14. All right. So what if I do a calculation and my calculation comes out to be 12.45 persons? Can I write 12.45 people?
No,
Oh
sir.
no, you'd have to either round up or down.
So if my calculation says the maximum capacity of a swimming pool is 98.75, what would be the maximum capacity of the pool? 98.75. What would be your rounded figure?
We that's a 98.
99.
No, but as in like 99 sound more than what it's supposed to be, you know, so that's how I'm looking at it. That's why. But if you're rounding
Yeah,
up,
but
it would of course be 99.
pause. If you look at it and I have 98, there's going to be a little bit more space that I can take at least one more person because I'm at 98.75. So it means that I shouldn't pass 99 people. So with this
Okay.
12.45 of ice cream, it means that if I sell 12, chances are, because it's more than 12, the value of Y came out to be 12.45. So it's more than 12. So if I do 12, it means that there's going to be a customer who chances are may come and will have no ice cream because I didn't make preparations for that person. Because if we are following the least squared regression equation tells us that if we expect 8 hours of sun, that we are going to be selling 12.45 ice cream. So it is in my best interest to prepare any number above 12. So the minimum that I could prepare is 13. So what Wayne decided that he's going to be doing is, I say the plan, I'm just going to make 14 as a just in case. Because if he makes 14 waffle cones, chances are, you're making the waffle cones and one of the waffle breaks and, you can't give the customer the broken waffle cone because the ice cream is going to leak out. So, you don't want the customer to be in front of you and you have no more waffle cone to serve the customer. You're going to lose that sale. So it is best if you have even one extra waffle cone as a just in case. The truth of the matter is, put it this way, if you are in entertainment and you are buying beverages for a reception, and if you calculate that each guest will get, say, 6 ounces or 8 ounces of a welcome fruit punch, and you know that you have 200 guests, what you have to do is to multiply 200 by 8 ounces and make sure that you have at least that volume of welcome juice, fruit punch, or else the guest will come and you're going to hear, oh, I'm sorry, we have no more fruit punch. And guess what? If it works out to be 15 volumes, 15 centimeters cube, or 15 bottles of whatever it is, 15 bottles of the 3.8 liters, don't just get 15. Because chances are when you're pouring, you have spillage. So you're going to need an extra one as a just in case. Am I making any sense?
Yes, sir.
Yes, sir.
Come on. So whatever is left is given back to the bride and groom. So that's why sometimes people buy things on consignment. So when you buy the things on consignment, you say to them, "Here the plan, give me 10 crates of an assorted mixture of red stripe, the flavored red stripe." So if you have the flavored red stripe out there, your guests will come and say, "I need a red stripe support," and so on. If at the end of the event, there are 3 cases unsold, you can carry back those 3 cases and be refunded because you actually took it on consignment. So you're expected to sell it off, but if it's not all consumed, you can go back with them, right? So this is one of the things that we do in in the whole business of estimating and the whole business of estimation. All right. Now, by the way, am I making any sense there? You understand what I'm saying?
Yes,
Yes,
sir.
sir.
Yes, sir.
One final example. One final example. Say, for example, you put on a baby room. You put on a baby room, and or you have a room, you have a helper's room that you're going to convert into a baby's room. And you decide that here the plan, I'm going to do a total renovation. So you're going to measure the length and the width of that room. And you decide that you want to tile the room. But when you are going about tiling the room, you recognize that you have a particular square footage. But when you get to the store, they say to you that you need X number of tiles. Say you need 26 tiles. You need 26 tiles based on the calculation. But it so happens that that particular tile or that tile is sold in boxes of 5. How many you need?
26.
26. What do you think that they will open the box and sell you 5 boxes at 25 and then open a box and sell you an extra one?
Man,
No, sir.
I
No,
never
they're
see
not.
that happen yet in my
It
life.
will never happen. So what the man I'm going to do is to say, "I'm sorry, but you have to buy 6 boxes. 6 5's 30." And say, "But it's only 26 I need." You say, "Yeah, put on the 4. Put on the 4." So that's exactly what it is, right? That's exactly what it is. All right. So as to ensure that you understand what is happening, I have another question. It says that the following data gives the distance between 5 randomly selected towns in Georgia, traveling by the road and taking the shortest distance between them, which is a straight line. And this question was actually extracted from Educasoft. So if you book up this question, you know exactly what to do. It is asking us to calculate the least squared equation. And then now it is asking us to calculate the correlation coefficient for the bivariate data. Remember, bivariate means the 2 sets of data, the X and Y value from here. Remember that?
Yes, sir.
Yes, sir.
Where X represents the road distance and Y represents a linear distance. Also indicate whether the correlation is positive or if it is negative. What I want you to do for me, since I've not yet taught you how to calculate the correlation coefficient, but we have done the least squared regression, I am projecting the set of bivariate data that I want you know. Remember that how many steps do we have in the question to calculate the least squared regression? Anybody remembers?
5.
All right. So you're going to go through those 5 steps, and you have those steps to calculate the least squared regression. I think I have done this question already. If not, I can go through the question with you. And I'm going to give you 2 5 10. I'm going to give you 10 minutes, 2 minutes per step to work on this. And then what we're going to be doing for the rest of the class is spending some time calculating the correlation coefficient. Fair enough?
Yes, sir.
All right. On the mark, get set, go. I'm muting. All right, guys, always stay. On it kind of sound way too silent for me, you know. Honestly.
Sir, may I go and do a thing?
Sir, still
Nice.
working on it, sir.
All right, cool. Asia, how you stay?
Working on it, sir.
Good job.
Sir, you can scroll up the steps tree and see if I'm up on the right track.
Absolutely. Did I send you this stuff?
No.
I never sent you the steps.
Uh-uh.
All right then. Don't say nothing more. I will send it to you just now so you can scroll for yourself. Send it.
All right. Thanks much.
All right, hold on, guys. The system is just not okay. Hold on. Let me try this now. Okay. All right. Hold on.
All right, sir, finish.
Yeah, I mean,
Pause the show off you, man.
Just say,
leave us alone. All right, I'm coming pause. I'm just trying to copy this thing. It was given a little bit of issue. Snaps, line of base fit. Oh, but you sure never sent it off to you? Because
Nope.
it is saying to
Mm,
me that it is there. All
I know,
right,
sir.
hold on. You have already. All right. So, all right. So clearly, I had prepared the document, but I never sent it off. So it is telling me that it's there when I'm trying to save it now. But let me
Oh, yeah, you did send it.
okay, because I know I would have done it. Yeah, man.
So me never said this. It just a come
Because
in from my phone.
because when I had done it, when I tried saving the document, no, it is saying to me that I already have something of that file name. All right, one word. Um, how far are you? Asia, how far are you?
sir, I'm at step 4. I almost finished step 4.
Okay, all right, good. So pause, just go and check over. I'll give the others after you to just finish off.
Okay.
Cool.
All right, sir. My dad step three. I so move on from my own.
Guys, I'm stepping out for about 2 minutes here. Soon come. All right. Mikey, how you stay? Finish now?
Not yet, sir.
Okay. Asia,
No.
finish now? No problem. Take your time, Andy, man. Take your time. Asia, how you stay?
I'm finished, sir.
Okay, good. Um, all right, Paz. What did you get for M?
I got 0.471.
Asia, do you agree with that?
Yes, sir.
Mikey, you got that right?
I got 0.4721. I don't
0.42. All right. So
I don't
so
know.
so what I
721.
what I got is 0.471. All right, we'll look at why you got two. Why you say you got 2-1?
21, yeah. I'm gonna
We'll
look
look
back
at
for the calculation to make sure I say the right thing right now.
right. Okay, Paz, what you got for B?
4.523.
Asia, what you got?
Sir, I got 4.529. Okay.
Mm.
So
All right. So
529.
I'm
all right. So
working B right now.
let me resume my share. Um. So let us look at our table values, the bivariate data, 14, 12, 20, 12, 11, 9, 17, 15, and 9, 11. Then remember, we're calculating x squared. Remember, we're calculating x squared. So x squared is going to be 14 squared is 196. Everybody have the 196?
Sir.
20 squared is
Yes, sir.
400. 11 squared is 121. 17 squared is 289. And again, we have the 121.
Yes,
Oh,
sir.
sir, this is supposed to work out y square as well?
Y squared eventually.
Oh.
And then we did xy. So you got the sum of x squared to be 1127
Yes, sir.
Yes, sir.
and xy to be 861.
Yes,
Yes, sir.
sir.
All right, good. So y squared is going to be done eventually. Eventually, when I'm doing the
The
B part, yes.
oh.
So this is what I did. Remember our formula? The number times um
The sum of XY.
xy, very good, minus the sum of x times the sum of y, all over the number times the sum of x squared minus the sum of x all squared.
That was my problem, sir, because what I had was
Uh-huh.
the denominator was number sum of x y square. That was throwing me off a lot. I was like,
Okay.
oh, I don't have that.
All right. So you see it now.
Yes, sir.
All right. So make that correction for me, please. So we're going to end up with 0.471. And then now we're using B. So remember now, if your M is incorrect, you think your B can be correct?
No, sir.
No, sir.
Nope,
That's rate out.
not at all, because you're going to be substituting your B into your M formula. So you have to be very careful. Be very careful
Hold
with
on,
your B
sir.
calculation.
Hold on. Don't move a muscle, sir. 435 minus 41. Yeah. 563. I got 5635. 4. That's why. Also, I see why I see the variation now. It should be 5635 and not 5634. So that's why I got the 2 instead of the 1.
Got you.
Mm-hmm.
Got you. All right. So what I want you to do is also to be very careful with the calculations so that these careless mistakes are not made. So we lose marks along the way. Meaning, if the question carries 30 marks, let us pick up the full 30 marks. Let us not make these careless mistakes. So we're losing marks as we go along. Why get 25 out of 30 when we can get the 30 out of 30? That's the point I'm making. All right. So B now is going to be the sum of y minus m times the sum of x all over the number n. And that is when he gave us, what he gave me was 4.5234. The question is, and I thought I was going to hear it. Do we
Where
have
you
to
get
use,
the y square?
work out the y square?
Yeah. You
Hold
still
on
not
a minute,
see
please. Hold on a minute, please. Don't move. Hold on.
just square the y.
No, but I don't see it applicable in the equation. That's why I'm asking.
You mean the one on the table?
Yeah.
Yeah, I get what you're saying.
Sir, if you're talking, we not hear you.
Yeah, man. Sorry. Paz, you were saying something a while ago, Paz.
No, I was just answering Michael about the Y square thing, but he was saying that he didn't see how it was applicable in the equation.
Oh yeah.
So
So the y squared is not going to be used to calculate the least squared regression. Look back at the formulation. You see, we don't have any y squared in here. So to calculate
Yeah.
m, we're not using any y squared. To calculate, we're not using any y squared. It's just y. I have the y squared up here because there's a part B to the question that I want us to look at now. It says a correlation coefficient for the bivariate data, where x represents the road distance and y represents the linear distance. It also indicates whether the correlation, so we need to also indicate from this calculation whether the correlation is positive or if it is negative. So let me introduce this to you now. So look at that lovely formulation. And see what I did? I colorize it because I want you to see what is happening. I want you to see what is happening. Now, if you look at it, it says to calculate the product moment correlation coefficient, or it is also called the Karl-Pearson correlation coefficient. This is a very ugly formulation that we have to use. So we originally use the sum of xy. We originally use the sum of x and the sum of y. Now it is that we have to use the sum of y squared. And now we're going to end up using the sum of y all squared. So you recognize the sum of y squared is different from the sum of y all squared?
yes, sir.
Yes,
Good,
sir.
good. So let me just see if I can break down this formulation to you, because the formulation is not bad. It really isn't difficult. Normally when I teach this after the first class, students generally get what it is saying. If you look at the formulation, you will see the formulation saying n times the sum of xy minus the sum of x times the sum of y. Does it look any familiar? Anything familiar with the calculation of n?
You're just kind of like transposing the x to the y. That's what you mean.
No, what I'm saying to you, let us look at the formulation for n. N in the numerator say n, sorry, not n, m, m as in Mr. When we're calculating m, it says it is n times the sum of xy, follow my cursor, the sum of xy, minus the sum of x times the sum of y. When I'm doing this here, is the numerator the same as the numerator for calculating m?
Yes,
Yes,
sir.
sir.
It is. So what I'm saying to you is that I'm not asking you to 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 do a new sort of study of this new formulation that I'm sending you. I'm not asking you to do that. This new formulation is going to be the same formulation as we use to calculate m, the numerator that is. The denominator is going to vary somewhat.
You just add you add a second section to the denominator.
All right, let us check. You know what I want to do? I want to copy this. Let me copy this and then paste it very close to this so that we can see what is happening here. All right, great. So, but sir, this n is a capital N and this n is a common n. N is n. And then the lowercase n is speaking about the number of terms that we use of the bivariate data. And the n right here for m is talking about the number of terms that we use for the bivariate data. So it's the same n. So the numerator remains the same. Let us look now at the denominator. Let us look at the denominator. Let us look at the denominator. The denominator is saying, n times x squared minus the sum of x all squared. Oh, but sir, it is exactly saying the same thing as m, except that you're finding the square root now of this denominator here, and you're going to multiply it now by using the x value. So if you look at it, if you look at this formulation, the numerators remain the same. This part of the denominator remains the same, except that you're finding the square root of it. True or false?
True.
True.
Good. And you're going to multiply it now by doing it again, but in this case, where you have the x squared, you're going to have y squared. Where you have the sum of x, you're going to have the sum of y. So you're going to find the sum of x, you're going to use the x values, you're going to use the y values, and you find the square root of these. Do you think you can remember that?
Yes, sir.
Come on, it's
Yes,
not
sir.
hard.
Yes,
The
sir.
formulation looks ugly, but it's pretty much, the formulation for m is pretty much that of r. The formulation of m is pretty much that of r, except that for the numerator is the same. For the denominator for m, all we're doing, we're finding the square root, and then we're going to multiply that by doing the same calculation, but instead of using the sum of x squared, we're going to say the sum of y squared. And instead of saying the sum of x all squared, we're going to say the sum of y all squared. Boom. And we get that formulation. Fair enough?
Yes, sir.
Yes, sir.
Just one quick question though, like how would know when to use this one or the first equation?
The question will tell you.
Just look on the question, read all of the question first, and then
The question will tell you. The question will say to you, correlation coefficient. Least squared equation is in the form y equals mx plus c. You're going to calculate the m, you're going to calculate the b, and you're going to put it in the formula. It's when I talk about the correlation coefficient is this r. So this common r is referencing the correlation coefficient. This common r is talking about the correlation coefficient. You follow me?
yes, sir, following so far.
Yes,
Right.
sir.
So once you're talking about the correlation coefficient, is that r that you're finding, is this formulation you're going to be using. So now that you know the formula, what I want you to do for me is calculate your column with your y squared now, and I'm going to project this formula. I'm going to project this formula that you're going to substitute in there, and you're going to calculate the value of r for me. I'm going to show you how easy it is. So I give you 5 minutes. Calculate the value. So you're using the same column, the same table that you'd have done, but you're just extending that table now to find the y column. So because I knew I had to do that, I went ahead and find the y column from before. So you're going to find the y column for me, and then now you're going to substitute in this formulation and calculate the value of r, and then allow me to help you to interpret r. Understood?
Okay, sir.
All right, cool, thanks. How is Steve? All right?
Sir, quick question. Two quick question. The
Mhm.
n in the small n is the same as the number of terms, right?
Yes, ma'am.
And when you calculate the two square roots, you're going to multiply them.
Yes, sir. Very good. So
Okay,
the square root here, this answer square root is going to be multiplied by this answer square root. Yes,
okay. Thanks much.
no problem. All right, no, we must get it now. We must get it. What we get for the answer?
0.7338.
Paz, got to get? Asia,
Yes, sir.
Paz?
Sir, me kind of did mess up the calculation.
I get 0.733. What do you say get? What do you say get, Mikey? 0.7338?
Yeah.
Yeah.
Sir, I got 0.773334 something something.
0.77. You said
0.
771?
0.7335 something something. So my biggest issue is the how
The
many
Rounding
decimal
up.
places and the
Yeah.
rounding off.
No,
Because for
don't
the
worry. No,
last
no, no.
one, that's for the last question I got. My last number I put 8, but the rest of the first numbers were correct. So I understand all that wrong still.
All right, because when I did my calculation there now, I'm getting, when I just did over the calculation a while ago, and I'm getting 0.733358865. What did you get when you did the calculation?
Me have a problem now with the rounding off problem. Thing, because I round off at 2 decimal places. That's why I
All
got
right, stop right there.
7338.
No, stop right there. Because normally when we talk about the correlation coefficient,
Yeah.
it is normally referenced using 2 decimal places.
Oh. So
So
I'm
when you
wrong there.
when you talk about R is normally talking about 2 decimal places. So if you put 0.73, perfectly fine. Matter of fact, I'm telling you now, whenever you're calculating R,
Papa
always
2.
report R as 2 decimal places.
Okay.
All
Because
right,
Sorry.
because
everything correct in sir. It's just that when you have 1, 2, 3, 4, the fourth one where you do the square root, you actually have like 4 decimal places for both. I only
right,
had 2.
right.
So everything is correct. It's just that is the only difference.
And guess what? The more of these questions we do, is the better we become at and know how to go about the running up. You know, some things in life you just do. One of the things that I don't want to get into the habit of is rounding up. I want to be able to appreciate a 7.3. What does a 7.3 represent? Right? Now, as we wrap up this question, the question said to us, to calculate the correlation coefficient, which is R, we just did that and got 7.3. For the bivariate data, by who variate the variables, 2 variables, X and Y. Data is just a set of numbers where X is going to represent the road distance. So X is representing the road distance and Y is representing the linear distance. I mean to also indicate whether the correlation is positive or if it is negative. Is the correlation positive or negative?
Positive.
Positive.
Okay. So hence, there seems to be a strong positive correlation between the given bivariate data. No, me want to tell me why me say very. You notice I said it's strong.
Closer to 1.
Very good. Excellent. Because remember, R lies between now -1 and +1. So you can have a strong negative relationship or you can have a strong positive relationship. You can have something that is moderate. You can have something that is, very strong. But this one is just as strong, 0.73 strong. What if I'd gotten 0.93? A very strong, you see the words that I'm using? The words that I'm using now is indicative of,
Yes, sir.
of how close it is to this +1. So what I'm saying to you now is that, here's the plan. You see the relationship between them bivariate data, yo? Them strong. So, yes, so it is going to be a strong positive correlation between the bivariate data. So as one value increases, the other one increases. As one value decreases, the other one decreases. So there's a nice little relationship between the bivariate data. A nice relationship working between them. Fair enough?
So, sir,
Yes,
if it
sir.
was negative, you'd say a strong negative correlation?
Yes, sir. So if that were negative 0.73, it would be a strong negative correlation. Sometimes you get the correlation to be like 0.3, you know, and you have to interpret it. Whoa, weak correlation. You know, sometimes, case in point, if I am doing, say, if I have a headache, I'll question myself and say, why is it that my head is hurting me? And then I will go back in the day and I'll say, did you eat lunch on time? Or did you have lunch at all? And the answer is yes, yes. I said, okay, how much water have you had? And then if the answer is yes, I said, okay, what happened there? Were you exposed to the sun? Because sun and me and my eyes, the sun pulls my eyes and causes my head to hurt me and hurt me very badly. So what I will do when I have a headache is I will go through like what a doctor does, go through a series of questions and try to diagnose. That's exactly what it is that you're trying to do. So in order for you, when you get your bivariate data, in order for you to tell me how the bivariate data, it will always be bivariate. It will always be bivariate. Why, sir? Because when I'm doing my correlation coefficient, it means that I'm comparing two things. Two things. I'm comparing Michael's age with his height. I'm comparing Paz's height with the amount of money he works. I'm comparing Asia's height with her shoe size. I'm comparing two things. Always two things that I'm comparing. Students' pass rate and the time spent in studying for exam. It's always two things that I'm comparing. How fast I'm driving to the how quickly I get to my destination. Always two things that you're comparing, right? And then the other part of this question now is to ask you to do a scatter plot. I will ask you to do that scatter plot for me. Today's Tuesday. I'll ask you to do that scatter plot for me. If you can get a graph paper, I want you to get a graph paper, and I want you to, on your x-axis is your horizontal axis. I want you to use your horizontal axis and we'll go up all the way to 20. Wow, all the way to 20. You notice you don't have any negative values, so we can just use an L graph. We have no negative values, so we can use an L graph. What am I asking you to do? So because I don't have any, what is wrong?
In a select, sir.
That's what I'm realizing. That's what I'm realizing. It's not safe. Oh my goodness, Michael, you really said call Asia football? Asia, pray for him. He's all right, man. He's out here, Asia, never mind. All right, I don't understand why this thing is not selecting. I wanted to show you something. All right, let me see something here. So let me unplug and replug.
Starting, let me get your calls. And your comment zone numbers are 733-248-1, 733-248-2.
I don't understand why it's not.
First name, give us your general location, income.
All right, guess what? Don't worry about it. On Thursday, God's willing, I'll go through the scatter plot with you. Do me a favor. Work with some graph paper now. So we can just do the scatter plot.
Okay, sir.
And then when we finish this, we would have completed this whole question. Now, let me just say one quick thing before we go. A question of this nature is a question that comes for about 30 marks. You see, when you calculate your least your different calculations, your correlation coefficient, and your least squared regression, all they're going to ask you to do is to interpret. All they're going to ask you to do is to interpret. So just make sure, say, everything that you would have done, your calculations will be on point. And then now you're going to use your values that you've gotten, and you can write a page and a half worth of essay, just like I did when I started the class, when I read some stuff for you, right? So I'm going to be spending some time on this so we can get this out of the way. The other areas that are left are some little small areas that we'll just go through. But what I try to do is to try to get some of the big boys out of the way so we can put up some of the marks. All right? Thanks for coming out. Big up yourself. Please go through, complete the work on Edico, and we'll talk later. All right? Take care.
All right, sir. Thursday.
Bye, sir.